Hello, welcome to Math 1324. This is Chapter 10, Section 4, Example 4. We just reached a 4-4. Finally. Okay, so I want to go ahead and solve 3 to the x equals 27. Here's the thing. We don't have anything that'll allow us to do that yet, but in fact, that's actually easiest to solve with logarithms, but we'll ignore that for now. What I want to do is I want to look at this theorem. The theorem says if a to the x equals a to the y, then x equals y. And this is true because a to the x and a to the y, they're both exponential functions, and the exponential functions are one-to-one. And what that means is if these two things are the same and they have the same base, the exponents have to be the same. That's actually kind of the definition of a one-to-one function. And I haven't really talked much about that. It's not all that necessary for us, but that is the reason that this works. So if a to the x equals a to the y, then x equals y. Why is that so helpful? Well, over here, 3 to the x equals 27, that is a little bit complicated if you're not careful, but I can realize that this 3 is a base, and this 27 also has a base of 3. What do I mean it has a base of 3? Well, if I take 27 and break it down into its prime factors, what do I get? Well, I get 9 times 3 and 3 times 3 from that. Notice that every single prime at the end is 3, right? And how many 3's? 3 of them. So what I could do is I can actually rewrite 3 to the x equals 27 as 3 to the x equals 3 to the third power. These are the primes. That's how many times they occur. And guess what? We're pretty much done at this point. The exponents have to be the same because the bases are the same. It's the great thing about exponentials. Easy peasy lemon squeezy. If you know your exponentials. Unfortunately, that's a big if. So you will learn different ways of doing this in Section 5. But until then, have fun.